Hello, everyone. So in this lecture, we're going to be talking about trigonometric identities and equations, and that is in chapter 9 of our textbook. So specifically, we're going to start by looking at solving trigonometric equations with identities. Now, recall that we started looking at a few identities in the last chapter, specifically the Pythagorean identity. So we know that sine squared theta plus cosine squared theta is equal to 1. And we saw this based on the inscribed triangle inside the unit circle. Now, from this identity, so I'll call this identity number 1. So from this identity, we can actually derive quite a bit of other identities, but we're only going to look at 2. So for instance, let's say I have sine squared theta plus cosine squared theta equals 1. Okay, so now let's say I divide both sides of the equation, meaning each term, by sine squared theta. Let's see what that will give us. Okay, so we know that sine squared theta divided by sine squared theta, that's going to give us 1 plus. Now, if we recall, cosine squared theta divided by sine squared theta. Now, that's going to be cotangent squared theta. And then 1 divided by sine squared theta is going to give us cosecant squared theta. And recall that these identities or these things that we're discussing here, we looked at them in the previous chapter. So I wouldn't say, oh, try to remember all of the identities that we're going to be discussing, but if you can remember the Pythagorean theorem, or well, the Pythagorean identities and the reciprocal identities, you should be fine. So this is going to be your second Pythagorean theorem identity, or Pythagorean identity, sorry. So 1 plus cotangent squared theta is going to be equal to cosecant squared theta. Now we can go back to the original sine squared theta plus cosine squared theta equals 1. Now, instead of dividing by sine, I'm going to divide by cosine squared theta on each side. Now we know that sine divided by cosine, now that's tan, so this is going to be tan squared theta plus cosine squared divided by itself is going to be 1. And 1 divided by cosine squared theta is going to be secant squared theta. And this is going to be your third Pythagorean identity. And so with learning your identity, it's going to take quite a bit of practice to come up with the different formulas in your head. But like I said, once you remember the first one, as well as your reciprocal identities, you should be fine. Also recall our even and odd identities. So recall that we had 4 odd identities. These are going to be our tan, cotangent, sine, and cosecant. So when it's odd, that means that whatever is on, so if we were to, let's say, draw the tan graph. So whatever is in the first quadrant is going to be in the third. So basically, it's going to be a reflection about the origin. And so what that tells me is, say, whatever is here, right, it's going to be in this third quadrant. So if I take tan of negative theta, it's going to give me negative tan of theta, and so on and so forth as it relates to each of our odd identities. Now we only have two even ones, and those are going to be your cosine and your secant. And if you think about, let's say, a cosine graph, if we were to translate it, you'll see that what's on the left is going to be on the right. So basically, cosine of negative theta is going to be equal to the same thing as cosine of theta, okay? So I'm not sure if that helped anybody, but we have 4 odd identities and 2 even identities. And these are the reciprocal identities that I mentioned, that if you were to know these in conjunction with your Pythagorean identities, then you should be fine. But we also looked at these in the previous chapter. So we can even go as specific to say for here, tan is actually sine theta divided by cosine theta, and cotangent is cosine theta divided by, okay, always good to know those. So why are these important and who cares, right? So let's look at some examples. So let's say we want to verify that tan theta cosine theta is equal to sine theta. Now, one thing we like to do when we're trying to verify or simplify trig expressions, you want to, as much as possible, rewrite them in terms of sine and cosine. That usually helps. So for instance, here, tan theta, we know that that's going to be what? That's going to be sine theta divided by cosine theta. And then we have times cosine theta, okay? And then another thing, you always want to like work on one side, and then hopefully you get the equivalent on the other. So we know that if you multiply these, you can put this over 1. If you cancel, you'll have that sine theta is in fact equal to sine theta, and we are done. So there are quite a bit of techniques. By the end of the chapter, we will see the different techniques. One is to rewrite in terms of sine, rewrite everything in terms of sine and cosine, and then go from there. Okay, so next we're asked to verify an identity. So we want to verify that 1 plus sine x times 1 plus sine of negative x is equal to cosine squared x. And they're telling us, oh, use the even and odd identities. So from here, I can notice here that I have sine of negative x. Now we know that sine is an odd function. So this becomes 1 plus sine x times 1. Now, since it's an odd function, sine of negative x is the same thing as negative sine of x. And we want to verify that this is equal to cosine squared x. So what do? Well, we multiply like we would when we have two binomials. So 1 times 1 is 1. 1 times sine x is going to give me a negative sine x, and then plus sine x, okay? And then this becomes negative sine squared x because we're multiplying two sines. So that becomes sine squared x. So we're trying to verify. I'd like to put a question mark until I verify. We're trying to verify that these are true. Well, these cancel. So we have 1 minus sine squared x. And so we want to figure out now, is this equal to cosine squared x? Okay, so remember I told you the Pythagorean identity, the first one that we had, we can come up with quite a bit, right? So we had that sine squared theta plus cosine squared theta equals 1. Well, if I were to subtract sine squared theta from both sides, well, what do I end up with? Well, I end up with cosine squared theta equals 1 minus sine squared theta. This is also a good thing to make note of. So what does that mean? Well, that means that on the left-hand side, I have 1 minus sine squared x. So this means that this is cosine squared x on my left as well as cosine squared x on my right. So that means that this has been verified. Okay. And so you may get like quite a bit of different identities to verify, and they will vary in different ways. So the way to get used to them is to actually practice. So be sure to do the homework problems so you can get practice on these. All right, so here it says to verify that sine squared theta minus 1 divided by sine squared theta is equal to secant squared theta minus 1 divided by secant squared theta is equal to sine squared theta. Now with this, I want you guys to note we cannot just cancel. Sometimes we are so tempted to do this. You cannot do that, okay? So be very mindful, this is wrong. But we can utilize our identities. So we can utilize our identities. Let's look at the numerator. So secant squared theta, we can actually rewrite that based on our Pythagorean identity above. Here, we have that secant squared theta is equal to tan squared theta plus 1. So I'm going to plug that in. So tan squared theta plus 1 minus 1. There's already a minus 1 in the problem. And I'm not going to rewrite this one just yet. I'm going to see if I need to rewrite the denominator. Okay. So I know that 1 minus 1 is 0. So I'll have tan squared theta divided by secant squared theta. And so I want to know, is this equal to sine squared theta? Well, let me break this apart a little bit. And so, like I said, this takes quite a bit of time. We can look at this as tan squared theta times, well, since this is in the denominator, you can look at it as 1 divided by secant squared theta. Now, tan we know is sine, so we can do sine squared theta divided by cosine squared theta. Now, if you guys recall the reciprocal identity, so 1 divided by secant squared theta, well, that's going to give me cosine. So we're using this one here. Okay, and so what do you note? And we want to know, is this equal to sine squared theta? Well, yeah, if we cancel the cosines, we have that sine squared theta is in fact equal to sine squared theta. Okay. All right, let's look at another example. All right, so here they want us to create an identity for the expression 2 tan theta secant theta by rewriting strictly in terms of sine. So in this instance, we're given the directive or the instructions to write in terms of sine. So let's see if we can break this down as much as possible with just sine terms. Okay, so tan, we can write that as what? Sine theta divided by cosine theta. We know that secant is what? 1 divided by cosine. Sorry, 1 divided by cosine theta. Okay. So then at the top, what do we have? So that means we'll have on our numerator 2 sine theta divided by cosine times cosine is going to give me cosine squared theta. Now, from this point on, we're trying to come up with an identity in terms of only what? Sine. And so here I have cosine. So I can go back to my Pythagorean identity where I had sine squared theta plus cosine squared theta, right? And so I want just sine. So if I subtract, which one do I want to subtract? I want cosine in terms of sine. So I'm going to subtract like I did before, sine squared theta. So you see, you can always come back here when in doubt if you need to. So I'm going to just plug this in. 2 sine theta divided by, so this would be 1 minus sine squared theta. So now I have everything in terms of sine. So this means 2 tan theta secant theta is equal to 2 sine theta divided by 1 minus sine squared theta. All right, so now here we want to rewrite this trigonometric expression. And so I believe in our previous chapters, not 8, maybe 7 or 6, we did something called U substitution. So if you notice, this is 2 cosine squared theta plus cosine theta minus 1. It kind of resembles a quadratic expression. So what I could do is let x be equal to cosine theta. So if I let this be x, well, that means x squared is going to be cosine squared theta. So let me go ahead and plug this in. So this becomes 2. And so I want us to make sure that this is what we're doing here. So 2x squared, okay, plus x minus 1. Now it looks like a regular quadratic expression that we can what? We can factor. So we need two numbers that multiplies to give us a negative 2 and adds to give us a positive 1. So this becomes 2x squared, multiplies to give us a negative 2, and adds to give us a positive 1. That's going to be positive 2 and a negative 1. Actually, you can keep it like this. So we factor out our greatest common factor. Put a negative 1 here. Since these two things are common, I can factor those out. And then I'm left with 2x minus 1. But remember, plug back in. Where we had x equals cosine theta, and x squared is what? Cosine squared theta. So I can plug this back in. So this means I have x's cosine theta plus 1 times 2 cosine theta minus 1. So this means when what's the word I'm looking for? When I multiply this back out, then I should get what I started with. So in other words, let me just write this explicitly. Okay. So once you write this out, this is what you should get. You could go further if you're asked to find theta, but we'll stop here because all they said was to rewrite. Okay, so now let's look at another example. Let me make sure. It seems I may have positive 2 minus 1 gives us a positive 1. 2 times that gives us a negative 1. That looks good to me. Yep. Okay. Alrighty, so now let's look at another example that's very similar to this one. So we want to rewrite the trigonometric expression for cosine squared theta minus 1. So we can do the same thing. We can let x, in this case, we're going to let cosine squared theta equal x squared theta. Equals x squared, rather. So then we'll have 4x squared minus 1. Hopefully we remember difference of squares. So with difference of squares, recall this means that if you have a squared minus b squared, it's going to be a minus b times a plus b. So then what do we square to get this? Well, 2x. What do we square to get 1? 1. So my a is 2x, my b is 1. So that means 4x squared minus 1 is going to be equal to 2x minus 1 times 2x plus 1. In other words, if I were to rewrite this whole thing, then we have to replace x, right? Because that's what we did before. So it becomes cosine squared theta minus 1 equals 2 so in this instance, then this means x is actually cosine if you take the square root of both sides. So this becomes 2 cosine theta minus 1 times 2 cosine theta plus 1. So that's how you would rewrite this. Okay. Alrighty, so next we're going to do a quick problem simplifying expressions. And so recall, like I said previously, when we're simplifying, you want to see, well, what do they have in common? If possible, you want to write them in terms of sine and cosine, just to kind of see what we have. So we have some squares, so possibly your Pythagorean identity is involved. So I think we can rewrite both of them. But since there's a cotangent here, and you really can go many ways with these type of problems, but you should get the same answer once you're simplifying correctly. I'm going to rewrite cosecant squared theta. So just so you guys know, I'm just going to be pulling that from here. 1 plus cotangent squared theta. So, for now I'm going to refer to them, but I'm going to just start writing them on the screen. Hopefully you guys familiar yourself with it. Okay, so 1 plus cotangent squared theta, minus cotangent squared theta. Well, if you notice, these cancel. So my answer simplified for this expression is 1. All right, so for this chapter or this section, really what we focused on was using the Pythagorean identity, the even and odd identities, and the reciprocal identities. But of course, there are quite a number of identities, but once you know these foundational ones, you should be fine. All right, so we'll stop here for today. Be sure to look out for your homework so you can practice doing these. Have a good one.